Hello everyone, my name is Dr. Ahmad and today we are going to look at the hypothalamus as a sympathetic outflow driver, and we'll also take a look at the applied anatomy case for the sympathetic nervous system as well. Without further ado, let's proceed. So hypothalamus is considered as a major sympathetic nervous system's driver. It is a part of the brain which is superiorly located above the spinal cord, and it will also considered as a major driver for the functions of the sympathetic nervous system. So on the right side, you will see the diagram. There is a green arrow coming down from the top, which is basically can be considered as a hypothalamus, giving its signal outwards towards the spinal cord. You see from C1 to T5 over there. However, the sympathetic nervous system is also called as the thoracolumbar system. So it will activate the preganglionic nerves of the sympathetic nervous system, which will then go out to the target tissue and carry out its function. So over here, we're going to start at one of the important cases of the USMLE exam, which is called as the Horner syndrome. It is also a case of the applied anatomy. You please remind yourself about the sympathetic nervous system, how it works, and how the distribution with the outflow tract actually goes out. So if there is a disruption in the hypothalamus outflow due to any pathology, that will cause the disruption of the signals from the hypothalamus, and the area that is affecting by the disruption is actually going to cause the Horner syndrome. However, in this case, it is going to be the output signal to the eyes. So when it is affecting the signal output to the eyes, it will cause the Horner syndrome. So the disruption is to be above the level of T1, the thoracic one, and majorly in the cervical spinal area and the sympathetic outflow. However, the disruption can also occur below the T1, but for the criteria for the Horner syndrome, the innervation of the eyes has to be disrupted. So the major nerve route to the eyes, we're going to have to look into that first. It actually starts in the posterior lateral hypothalamus and ends with the long ciliary nerve that supplies the iris dilator muscles and the superior tarsal muscles of the eyes. So in this diagram, you look, let's start from the left side. Over here, there is a posterior lateral hypothalamus. You see these nerves going down. These are the descending sympathetic pathways to the upper thoracic cord. You see these coming down, making synapse. However, the synapse is actually making into this superior sympathetic cervical ganglion. It goes down, and for the sympathetic nervous system, it enters through the T1 level or above, and then go into the sympathetic chain in itself and make a synapse with the postganglionic nerve fibers. So these postganglionic nerve fiber, as we learned before in the previous video for the sympathetic nervous system, the postganglionic nerve fiber actually hitchhikes on the major arteries. In this, it is actually going to the carotid plexus. So you see these nerves, they are supplying to the tarsal muscles right there, nerve to the iris dilator muscles, and also the nerve to the sweat glands. So these, any disruption to one of these or all three of these nerves is actually going to cause the Horner syndrome. So it is characterized by three oses. So the osis is a suffix, and any of the three symptoms is gonna be elemental to the Horner syndrome. The very first one is a ptosis, which is a partial drooping of the upper eyelid. The second osis is a meiosis, which is a constriction of the pupils, and the third one is the anhidrosis, which is the absence of sweating. So there are three places where the lesion can occur on its pathway to supply the eyes, and that is actually making the major division of how the Horner syndrome can be further classified. So it's divided into first order, second order, and the third order. So the first order is also called as the central Horner syndrome, which is caused when the lesion is present on the central nervous system. So that could either be present at a brainstem or the cervicothoracic spinal cord, and the pathologies that could be involved are stroke, tumor, or demyelination. The second order is called as the preganglionic Horner syndrome. It is caused by the lesion that involves the spinal cord, thoracic outlet, or the lung apex. And these lesions are usually acquired through trauma, surgery, or malignancy. For example, the Pancoast tumor, which is present on the apex of the lungs, can cause the Horner syndrome, but it's going to be the second order. The third order is the postganglionic Horner syndrome, and it is caused by the lesion of the internal carotid arteries, such as arterial dissection, thrombosis, and many other. So, from the USMLE examination point of view, the Pancoast tumor is more important. As we discussed just now, the tumor is present on the apical portion of the lungs, and when the tumor grows, it may suppress the sympathetic outflow to the eyes, causing the symptoms that are mentioned above. Once again, the symptoms are ptosis, meiosis, and anhidrosis. So, with this slide, we are going to end our presentation, and I would request you to please follow my channel for more videos like this. Thank you so much.